Hello students, welcome to the Team Curiosity e-learning classes. In this lecture, we are going to discuss about photoelectric effect. We know that light shows both the nature, particle nature and wave nature. Wave nature of the light would get characterized by the phenomena like interference, diffraction and so on. Similarly, we can conclude the particle nature of the light by the phenomena like blackbody radiation, photoelectric effect and Compton effect and so on. In this video, our prime focus will be about particle nature of light showing the phenomenon of photoelectric effect. In 1887, Hertz discovered photoelectric effect which provides the direct information for energy quantization of light. For the students who don't know about energy quantization, it's actually is the phenomenon in which electron can absorb or radiate in the limited amounts. Let us know about photoelectric effect, which is a particle nature of light basically. In this effect, which further develops one of the greatest mechanics in science, which is known as quantum mechanics. Let us discuss briefly about the term photoelectric effect. Photoelectric effect is divided into two terms. One is photo, another is electric. Photo is light, we know it very well, and electric is the electric current. So, what itself gives us the valuable information about from the light how we could develop a current. And this phenomenon is regarded as an photoelectric current. From the above animation, which you all might be seeing right now, that when a certain frequency of light is tracked on the metal surface, then it emits electron, and this process of emission of electron is referred to photoelectric effect. Now, let us discuss about some of the laws of photoelectric emission. So before going to that, let us understand some of the terms related to photoelectric emission. First of all, work function. What is work function actually? Basically, work function is the minimum amount of energy required to free the electrons from the metal surface. This is called work function and it is actually the property which is inhibited by the metal itself. Second term is threshold frequency. It is the minimum frequency of incident radiation below which photoelectric emission is not possible. Now let us go towards laws of photoelectric emission. First law is frequency of incident radiation should be greater than threshold frequency. Second law is maximum kinetic energy of photoelectrons depends on frequency of photon, but it does not depend upon the intensity of radiation. Third law is number of photoelectrons is directly proportional to the intensity of radiation and does not depend upon frequency. Fourth one, photoelectric emission starts as soon as radiation falls on the metal surface. Now, let us discuss about experimental investigation on the photoelectric effect to determine Einstein's photoelectric equation. From the above animation, we could see briefly that C is the photosensitive plate, which is called emitter, and A is the metal plate, which is called collector. A transparent window W is fixed over here, which is sealed on the glass tube, which can be covered with a filter. And this filter is used to regulate the light of the particular wavelength and frequency to pass through it. This is all about the construction. Now let us discuss about the phenomenon, how this process is undergoing. When monochromatic radiation of suitable frequency, which is obtained from the source S, after being filtered, it then fall on photosensitive plate C and photoelectrons are emitted from C, which can get accelerated towards plate A. The electron then flow outer circuit and hence deflection is observed. From this experiment, Einstein deduced some equations which is referred as Einstein's photoelectric equation. According to Einstein, light of frequency mu consists of corpuscles or photons, each of energy h mu. When a photon of light of frequency mu is incident on a metal, the energy is completely transferred to a free electron in the metal. A part of energy required by the electron is used to pull out the electron from the surface of the metal and rest is utilized in imparting kinetic energy to emitted electron. Let phi be the energy spent in extracting the electrons from the emitter to which it is bound and half mb square be the kinetic energy of the photoelectron. Then h mu is equal to phi plus half mb square. Let this as equation 1. Here h is the Planck's constant, mu is the frequency of light, phi is the work function, m is the mass of the emitted electron, v is the velocity of the emitted electron. This relation h mu is equal to phi plus half mb square is regarded as Einstein's photoelectric equation. If mu naught is the threshold frequency, then phi is equal to h mu naught and phi is the work function. Then equation 1 will be h mu is equal to h mu naught plus half V maximum square. Let us mark this as equation 2. And V max over this case is the maximum velocity acquired by the electron. Now half V maximum square is equal to h into mu minus mu naught. Let this be equation 3. This is all about today's video. In the next video, we will discuss about various relations and also graphical representation. Thank you.